Thanks for coming out today. Definitely as folks are filing in, come up to the front. I don't bite much. Wes might get spit on, but that's on him. He's too close anyway. So welcome. Today I'm going to talk a little bit about zero trust. We're going to cover a few different things. We're going to cover these four things primarily. We're going to get a working definition for zero trust that hopefully is like tangible for folks. I'm really tired of the FUD around zero trust. So we with the SP got a very specific definition. I'm going to introduce that as identity-based segmentation. We're going to discuss a possible way that we can implement that using a service mesh as one of the architectures. And more generally, I'm going to outline how we can move incrementally from network-oriented policy into identity-based policy. So a lot going today. Why am I here talking to you all about it? I was one of the early engineers on the Istio project, one of the more popular service meshes. Before then, I worked across Google Cloud on a whole bunch of different stuff. I kind of jokingly say, if you do like enterprise-y things in Google Cloud, I probably worked on some of that code. Specifically like projects were my baby for a long time. From there, we actually did very meshy things at Google and deployed that architecture internally and said, hey, we think this might solve some powerful problems in the Kubernetes space that are coming up. And that's when we then started to work on the Istio project. One of the other big hats that I wear, and probably the biggest reason I'm here talking to you today, is that I co-author a set of security guidelines with NIST. I work on two sets. The 204 series, SP 800 204 A and B, I helped write, which provide guidelines for microservice security. The second one, which is hot off the press, in fact, it was just finalized. It's been in draft for a few months, but it was just published about 1 month ago, 207A, and that's all about zero trust. The 207 series is NIST's series on zero trust, and 207A is the second installment in that, and that's really what we're going to be digging into today. This is relatively new stuff, and again, we're going to break it down in this way. So first, let's take a step back and what does zero trust actually mean? Right, and we'll walk into a definition, but the key thing I want you to understand is that a motivated attacker can already be in the network. So the question is, how can we limit the damage that they can do? It's all about risk mitigation. So I want to kind of take a step back and then we'll build into a definition. So something hopefully most folks in this room are familiar with is something like an API gateway or just serving an application to end users, right? There's a couple things that we always do. We always authenticate the user when they come in. We hopefully always authorize that user to take some action, right? If we're talking about an API gateway, maybe we additionally do some rate limiting. Maybe we have some other policy like WAF that we might apply. There's a bunch of different stuff that happened in the front door. But two big ones are that we always authenticate and authorize the user. So as we're thinking about, somebody can be in the network, somebody can be inside the perimeter, how do we minimize the damage? Then, definitely we probably want to start to do that same kind of authentication and authorization for the workloads that are communicating as well. So not just do we have a user in session, but do we know what is talking to what those users are using? We want to be able to say, hey, the front end can call the back end can call the database. And on all those hops, there better be a valid end user credential. And maybe we might even go further and we might say, hey, if you're going to do a put on the front end, you better have the right scope in the end user credential. But if you're just going to do a get, then maybe you just need the read. And so we can build really powerful policies as we start to combine these. Again, I led off with the attackers already in the network. Every single time I give a variation on this 207A talk, there's a different example that I can cite of a network breach. In this case, for folks that follow the news, just yesterday or the day before, I believe, there was a big bulletin put out by CISA in conjunction with Japan about network breaches driven by China in a variety of networks, for example. That one's very relevant. This one is from a decade ago. If anybody know offhand where that picture is from, I'll tell you in just a second. But that is actually from the Snowden leaks, right? Where the U.S. government was in infrastructure. So the point here is that a motivated attacker can be inside the network. So if our only control, if our only security is at the perimeter, then you're already cooked. So this then brings us into zero trust. So we want trust that is explicit. I actually hate the phrase zero trust, by the way. It really should be called zero implicit trust, because it's all about making where we have trust in the system explicit, and hopefully doing that with a policy so that we actually have like a piece of code that enforces it, right? So we want trust that's not based on the perimeter because it's breachable. Therefore, instead, what we need is a decision that's based on least privilege, we want to do it per request, because requests can be, you may be doing different actions. We want it to be context-based. If you're accessing from the US a whole bunch, and then randomly 5 minutes later, you're accessing from an entirely different geography, something's probably a little fishy there, right? So we want to have context-based decisions. And again, those need to be on identities. And more than just service identity, we also want end-user identity, and potentially also we want device identity, right? Because all of those factor into the context for how we want to allow a user to access a system, right? If I'm on a corporate-approved device and I'm logged in and I'm coming from my home geography, I probably can have a lot of access. But if I'm on an untrusted random device that's popping up in a weird geography like Russia or Eastern Europe or something like that, then probably I want to give less access to that, because that's not typical for how the system operates, right? Okay, so with that kind of high-level definition for zero trust, let me bring in identity-based segmentation. This is the main thrust of 207A. We define a few different things, probably 3 things in 207A that I'll talk to you about, but identity-based segmentation is the big one. Again, like I just said, we want to isolate, for folks that are familiar with microsegmentation, that's isolating network workloads at the network level, right? And ideally, we want to do that down to the individual IP address. So we have pairwise policy for who can access whom. We want to do the same thing at the identity layer. So we want tamper-proof, cryptographically verifiable identities for the user, for the device, for the service. We want to use those identities to make that previous decision that I talked about, this context-based, per request, least privileged decision. And ideally, we might use network parameters as part of our risk-based assessment, but they should not be the only discriminant that we're making an access decision on, or we're going to be cooked, because a privileged spot in the network is not a good enough security boundary today. So what is identity-based segmentation? It's these 5 things. So if there's anything that you walk out of this talk with today, this is it, please. These are the 5 runtime activities you need to be doing at minimum these things, and you can call yourself a zero trust posture. Right? There's a lot more we can do besides these, and maybe should do besides these, but this is a minimal working definition. We want 5 things. Encryption in transit, and really we want this for 2 reasons. 1, we want message authenticity. I want to know that somebody can't change the message that I sent. And then 2, we want eavesdropping protection. I want to make sure that somebody else can't look at the data that I'm sending if the data is sensitive. Then on top of that, we want to know what are the workloads that are communicating. Is the front end calling the back end? Is the database calling the front end? Like, is that which parts of our system are communicating from a software perspective we're deploying? And then with identities, we should authorize that access. And again, we should do that per request. And then exactly like I said before, we want to additionally incorporate that end user credential and end user authorization decision as well. So we want to do all 5 of those things. Ideally, we want to do them at every single hop in our infrastructure. And if we achieve that, if we're doing this, then our answer to, hey, what happens if there's an attacker in the network? Hopefully we have a pretty decent answer, right? Because the answer is now they need to steal a credential. And we'll get into the model a little bit more, but they need to steal an end user credential. They need to compromise a workload or steal a workload credential. Those are very ephemeral credentials too. The workload identities, and I'll talk about the service mesh in Istio in particular, workload identities may last 24 hours or even as little as 1 hour. End user credentials typically last on the order of 15 minutes or so without refresh, right? And so we can start to combine these things. We start to limit an attacker in time and in space. We mitigate the damage that they can do. And I'll touch on this more. So the service mesh is one of the key ways that we discuss implementing this in the SPs. It's not the only way that you can implement these capabilities, but it is a very powerful way to do that. And I'll dig into that in just a second. And if you're interested in some of the other use cases beyond identity-based segmentation, there's some of the other SPs that cover microservice security that go into service mesh a lot more. So how can we use a service mesh to do this segmentation? So just to level set for everybody what even is a service mesh, the key idea there is what we do is we take a proxy, a web proxy, like a reverse proxy. In Istio, we use the implementation Envoy, but you could think of something like an Nginx or similar as well. And we put that beside every instance of every single application, and we force all network traffic into and out of the application through that proxy. What that lets us do is, have an application identity and do encryption on behalf of the application. We can make load balancing decisions on behalf of the application. We can do service discovery and load balancing, and we can do things like resiliency, timeouts, keep alives, retries on behalf of the application. And you can get operational telemetry out of the system to help you close the loop. So when you make a change, you can see what the effect of that change is. Is it doing what you intended or not? And then change it, again, if it's not. So again, there's quite a few capabilities here. I would argue that if you're going to have any distributed system, you have to have these capabilities, right? So the service mesh is not novel in bringing these capabilities into play. But what is novel about the service mesh is that it lets us do all of these consistently across your entire fleet of applications, regardless of the language that we're in, because we're working at the network level and we're intercepting network traffic. It gives us centralized control. So we have those proxies, that sidecar beside every application instance. We have a central control plane that manages it. We can push declarative configuration to that control plane, and it will enact that configuration on all the sidecars in the order of less than a second, typically. So we have a very fast, very responsive system. We can see signals out to see if it's in the state that we want it to be. And if it's not, we can push configuration, have it go into effect almost instantaneously, and then watch and see if it is in the state that we want it again. So, I mentioned I worked on Istio. Istio is the most widely deployed mesh. Envoy, the CNCF project, Istio is also a CNCF project now, but Envoy, the CNCF project, is the data plane there. So Envoy is handling the bits and the bytes of your request. It's the sidecar. And Istio is what's programming that Envoy at runtime. So a couple kind of key ideas that I want to give y'all as well as we're thinking through this framework of how do I limit access for zero trust, and how might we use a service mesh. So the first key idea is that sidecar forms a policy enforcement point. So the idea is because it's intercepting all the traffic in and out, we can use that to put whatever policy we want. So I mentioned things like encryption. I mentioned things like observability, but we can also do things like integrate with OPA. We can do things like integrate with our identity provider to do SSO on behalf of applications. There's, we can build a custom library that does something that's specific to our business and enforce that it's called via the service mesh. So the idea is that when we have policy that we want to apply across the board, not just to one set of applications, but to most applications in our infrastructure, we can leverage integrating it once with the service mesh to do the enforcement and not have to go app by app. In this, if you go back to the old school access control literature from like the 1970s, that's where the notion of a kernel comes from. That's where we talk about the idea of a reference monitor, the thing that intercepts all the traffic and enforces policy. So then extending that, the service mesh itself, and this is one of the key ideas why the NIST folks were so interested in the mesh, can potentially be that security kernel for our modern distributed system. So if we think of the operating system kernel and the security capabilities it provides for processes that run on our operating system, it provides isolation. These days it provides C groups and namespaces to provide soft multi-tenancy with containers. It provides the permissioning, the Unix file permissioning as another mechanism of access control. There's quite a few access control systems that we build into the operating system kernel, and we leverage them to protect our applications. The idea is that the service mesh can be the same thing in our distributed system. So rather than deploying processes onto a host, we're deploying microservices into our infrastructure. But in the same way that the operating system provides a key set of capabilities regardless of the application, The service mesh can provide a consistent set of security capabilities regardless of the app that's running. And so in this way, the service mesh facilitates cross-cutting change, right? I mentioned we can integrate whatever policy it is, whether that's traffic routing, whether that's security, observability. We can integrate that into the service mesh to enforce it. We can change it and manage it centrally, which means that a small group of people can act on behalf of the entire organization to enact policy and make change. So we can think about it, there's no free lunch. We can't get rid of the complexity. We want to do encryption everywhere. Somebody still needs to integrate with a PKI and get certificates there. The service mesh lets you do that one time, integrate it with the service mesh, and then all apps benefit. One example, right? So it can be a force multiplier that we can use to concentrate the complexity that we need to deal with on a small team that's well equipped to deal with it, rather than, for example, in the case of encryption, needing to make every app team go and implement some encryption library in their own system, right? So to bring this back, if we look at our 5 tenets for identity-based segmentation, we can use the service mesh to achieve all of them. First off, we can achieve encryption in transit. The service mesh gives you a strong application identity. We use a system called Spiffy to do this, and we issue a normal certificate that encodes the application identity, and we can use that to do encryption in transit, mutual TLS specifically. Then using that certificate, we can authenticate our workloads that are communicating, which means then that we have the opportunity to apply authorization. So we know exactly what workloads are communicating, we've authenticated them, we know for real it's them. So now we can actually decide, hey, is the front end allowed to call the database directly? No, probably not. It needs to go through the back end, right? And we can start to enforce that kind of policy. Then we can integrate the sidecar as a policy enforcement point for our existing identity and authorization system for end users. So the service mesh itself is not well suited to model user to resource access or that kind of thing. It's good at modeling service to service access, but we want to delegate out to our existing systems to handle end user authentication and authorization. And the service mesh provides tools for integrating with those systems. So the final thing that I want to cover then is how can we start to move incrementally from the kind of current system that we have today, a perimeter-based system, into some of this identity-based policy, and what are some of the benefits of doing that? So first off, policy at any one layer is going to have shortcomings and pain. So if we think about just network policy and identity-based policy, one of the biggest pain points with network-based policy today is it usually takes a long time to change. So who are folks, who here has a firewall in their organization that they have to go change when they do stuff, right? So who here can change the firewall in less than 2 weeks? Yeah, that's what I thought, right? Normally, every single organization I think I've ever talked to it's 6 weeks to change the firewall. I don't know why it is, but it's how long does it take? It's 6 weeks. Got to go to the spreadsheet, got to find the CIDR, got to make, So it's not well suited for the highly dynamic environments that we're deploying in today. Cloud in particular with auto scalability and things like that are not well suited to traditional network controls. So we either need to use more sophisticated and usually more expensive technology to do that, or we need to hamper our ability to use things in cloud, slow down the organization to fit it into the existing process, which is kind of a non-starter. Identity-based policies, and this is something, as an industry, we don't have a lot of experience managing identity-based policy in this sense, in the same way that we have with network-oriented policy. So some of the challenges are people kind of haven't hit yet. One of the more obvious and initial ones that you hit is that even something simple like a service has a different identity in different domains. If I'm running it on-prem on a VM, it probably has a Unix username that we've allocated in our system for it to run as, right? But if we're in cloud, GCP, it's gonna have a service account. And if it's in AWS, it's also gonna have a service account, and Azure and any of the other ones. The problem is those service accounts aren't the same. So if I wanna do something like describe the front ends can call the back end, and I wanna do that regardless of where the two are deployed, then there's some complexity in how I map those identities across different identity universes, like different cloud providers and on-prem. And then finally, the other kind of big, 800-pound gorilla in the room is that even if we totally bought into identity-based policy and we say, yes, that's the way, in most regulated environments, we can't actually get rid of the network-based policy yet. Because either auditors or regulators expect it, or I have a document that was written in 1992 that sets the security posture for the organization, and it says that there have to be network segments, and it's more expensive to change that document than it is to pay Cisco millions of dollars to do network segmentation. All right. So for a variety of different reasons in organizations, we can't totally eliminate networked oriented policies or network level policies, even if that's desirable. And I don't think it necessarily is. So instead, we want these two layers to live together. And what we would like to do is start to trade off between the two so that we can minimize some types of policy in the network level, offset them with identity-based policies, and the hope is that we can get more agility out of our system as a result. I'll give you some specific examples of doing that in just a second. So if we talk about multi-tier policies, there's at least two, there's many more layers of policy actually, but this is we try and keep the SP very short and focused. It's about 18 pages long, about 12 pages of content if you want to go read it. Most SPs tend to be 50 or 60 pages long, so we really kept it focused. So at minimum, two policies, network tier policies, things like firewall rules. Identity tier policies, things like I just talked to you about, like application-based, strong identities with authorization. And so what we can start to do is where we need to do things like traverse a firewall, we can start to incorporate identity-based policy and relax some of our network rules. So in particular today with a network-oriented scheme, when I have two applications, maybe one's on-prem and one's in cloud, or it's my two on-prem data centers or two different cloud providers, doesn't really matter. And I want them to be able to communicate, I typically need to go change the firewall rules in my organization pairwise. I need to say this app, app A can now call app B, right? Or service 1 can call service 2. And if tomorrow service 1 needs to call service 3, I need a new firewall change and I'm back in the 6-week cycle of firewall updates. And this is a huge killer of agility in folks that we talk with. So instead, what we can do is deploy identity-aware gateways. So instead of having these pairwise rules that we need to update regularly, we can deploy these identity-aware proxies or gateways, instantiate a single set of firewall rules that say these two sets of workloads can communicate. And then when we have pairwise applications that need to consume, we can authorize that with an identity-based policy that says, hey, service 1 and service 2 can communicate over the bridge. And so in this way, what we've done is we still have all of our network controls. Our user request still traverses all the network controls that the organization already had, but we've been able to offload the policy change from network to identity. And the key idea is that a network-based policy is a CIDR range, and who knows what a CIDR is and what app it is. But an identity-based policy should correlate very strongly to the application that's running. If your runtime identity doesn't match the application's identity internally, something's probably a little funky, right? We want these things to line up. And so typically, we can change an identity-based policy much more rapidly because a human can read and understand the front end in the default namespace, wants to call the back end in the default namespace, a heck of a lot more easily then I can understand that 10.1.2.4/2030 can call 10.2.5/24. Right? Who knows what that means? And that's why we can get a faster rate of change by offloading here. And more than just 2 layers of policy, typically we have quite a few layers of policy in our systems, right? So we typically have a coarse-grained segmentation of internet, intranet. And likely we have broad segments there, a DMZ, an app zone, a business zone, the data zone. Then we tend to, again, we already tend to stack these policies today, right? So for folks that implement micro-segmentation in their networks, how many of y'all did away with your coarse-grained segments when you moved to micro-segments? The answer is we tend to keep both and stack them additively. And then Kubernetes brings in a whole additional challenge because it's a virtual network. And so we have a new set of techniques like the CNI providers to control network policy there. Those have some better trade-offs versus traditional network rules because they're built for the dynamism. right? But fundamentally, there's still a layer 4, layer 3, layer 4 policy, whereas we really want to get application identity and end user identity. Those are layer 7 things. And so that's why we like to see the service mesh stack kind of on top of all of these. And so I think of it as almost a layered cake as we're going up. You can think of it as Swiss cheese if you really want to think about the defense in depth, right? We're trying to make it hard to get through. So, why would we do this? One, if we do it in this way, then we can start to sit these new identity-based policies on top of our existing network policies. It provides a defense in depth because, again, we're still going through our traditional network controls, but we now have this identity layer as well on top of the network controls. And of course, the service mesh I already mentioned is it can enforce this because it's non-bypassable, it's verifiable, and we talk about this at length in SB 800-204B. And again, the key thing that I want you to take away is that we don't need to get rid of firewalls or WAFs or similar, but what you should feel comfortable in justifying to your organization is that you can relax those controls in exchange for introducing identity-based controls. And the key is in your organization to get the right balance so that you can still move fast, but keep the security and the risk side where it needs to be for that part of the org. And so at a high level, how would we start to do this? What we want to do is begin to implement identity-based segmentation in the subsets of our infrastructure, right? So if we have multiple data centers, start by just trying to implement that policy in data center. Then after you have a good notion of this identity-based segmentation, then we can start to do some of the more advanced patterns like tiering these gateways together and some of those patterns as well. Certainly you don't need to have like 100% identity-based segmentation ruled out to be able to do some of those gateway style patterns. But you do need at least enough to be able to authenticate and authorize the services and the users that are going over that tunnel. And again, same controls that the user app traverses. That's key, right? Because we don't want to have to go change the existing security policy, but we do want to make things better where they are so that we can move faster as an organization. And with that, I think it's time for questions. We got through a little bit more quickly than I had anticipated. One thing I do want to talk about just real quick, I thought I had a slide, but I missed one. I mentioned, the big mental model when it comes to zero trust, we want to bound an attack in space and in time. So we want to minimize what an attacker can do inside. I normally have a slide on that and I missed it in this one, but one of the key things there is that by stacking these identity-based policies with the network-based policies, we help bind an attacker in space and in time. So obviously network-based policies impact when an attacker can pivot to attack when they already control one workload. In the same way, fine-grained authorization policies at L7 help limit the blast radius of what an attacker can get to. And then like I mentioned, those ephemeral credentials. So end-user credentials usually have a 15-minute expiry. In the service mesh, service credentials tend to have anywhere from 1 to 24 hours expiry. So for an attacker to perpetrate an attack, they need to have both the service credential and an end-user credential. And they need to have the right scopes so that we can actually get through and pivot to the system that we actually want to target. And because of the expiry, I need to either have a persistent control of the workload so that I can continue to re-steal those credentials, or I need to perpetrate an attack repeatedly to re-steal after they expire. Either way, the goal is make it as hard for the attacker as possible. Both of those schemes help increase the difficulty, help bound an attacker in space and time. So with that, please, questions, comments, concerns, rebuttals? Oh. Thanks.
Thank you. Question, with all these identities and fast-moving credentials, I think debugging of this configuration will be tricky. Do you offer any tooling like formal tools to verify?
Yeah, so this is an area that's still pretty nascent today, but this is why one of the things I stressed was, the service mesh, and one thing I want to be clear, the service mesh is not the only way you can implement those controls. There's a lot of ways that you can implement those. One of the advantages of the service mesh is that it produces metrics out. So you can actually observe what is the state of the system, let me apply a policy, is it correct or not? What we're starting to see then is tooling built on top of that, and it's still early days there. But for example, in one of the things we have is a CLI that'll basically say, hey, give me 30 days of telemetry data, and I'll spit out for you fine-grained authorization policies that model that 30 days of access. Right, so tooling is getting there, but it's still very early days for it, and that's one of the things I think we'll see mature pretty quickly, I hope.
Thanks. Great talk.
Thanks.
And since you mentioned service mesh is just one leg,
Yeah.
I dropped in for this one. Service mesh is kind of a big pill to swallow.
Yeah.
Non-trivial thing to implement, especially at like some very large company scale if you want to run on a single control plane.
Yeah, yeah.
15%, a large single point of failure, et cetera, et cetera. So for those of us, well, maybe sell us on service mesh if you want.
Yeah.
But what recommendations do you have for those who aren't going to solve that?
Yeah. So in this world, consistency is your biggest asset. So how would I, if I'm coming at this kind of de novo, I'm either a small organization or I'm trying to approach this without service mesh. I'll come back to why there's some maybe modern deployment things that we can do with the service mesh that mitigate some of the pain you have, but not all of it. In short, what I would start to do is focus on libraries, right? So for example, if you're in a smaller organization, I know you didn't necessarily ask about smaller, just people that don't want service mesh, when you start smaller, it will go up. Where hopefully we have a consistent set of languages that we're dealing with. Hopefully, especially if you're like a pretty small shop, you have exactly one language that you're dealing with. In which case I would say, first off, make it a monolith. And secondly, implement those exact 5 controls, but just do it in library, right? Nowadays, you can get pretty far with a framework like gRPC. Even regardless of language, you can get pretty far with a framework like gRPC with respect to implementing all 5 of those controls. So my first piece of advice would be something like that. Tackle it with either a library, if you have a very small set of languages. If you're a small shop with a small number of services and small number of developers, don't do microservices. Why would you do that? Talk to me after if you want to hear about that. But keep it as a monolith for as long as you can get away with. Keep things simple for yourself, right? So that's how I would start. And then again, as we're growing up in scale and heterogeneity, either you allocate a bigger team to do things like that library work in the different languages that developers are developing in. And there's a set of challenges there around update and deployment and lifecycle. And eventually that's where we see kind of the tipping point for service mesh to become kind of interesting for folks, is that the work to maintain a consistent set of libraries, update it across the organization, and have compatibility across different versions and all of that tends to be expensive. And so things like gRPC make it a lot more tractable, and not just gRPC, you could do Spring Boot or other things. But somewhere along that journey, it tends to be that the service mesh starts to become more attractive. There's also a lot of things you can do these days to have more refined blast radius with your service mesh deployment. In particular, we would recommend keeping them one-to-one with your Kubernetes clusters. So that you have a refined blast radius there that is your cluster. And then there's a set of techniques that you can do to either shard workloads in the cluster if you're really huge scale and you need multiple control planes. Or there's a set of configurations that you can use with the service mesh to help limit what config has to flow where. Things like an Istio, the sidecar API resource, that gives you much better performance overall. The final thing I'll mention is coming soon is in Istio world is Ambient. That is a node level proxy that does some of these capabilities. And that is yet again a cheaper way to start service mesh adoption in places where you don't have these capabilities yet.
So I work for a large packaging company, and it's a very diverse shop. The moment we bring up zero trust, it's always the networking team that comes into the picture and they say that, yeah, we protected the network. Do you have any recommendations where how we can make the case or convince the senior leadership that zero trust does not stop there?
Yeah.
Go up to the application?
Yeah. Show them this 207A. That's why I wrote it. But no, I mean, like, legitimately, this is a big problem that we hit all over the place. So I'm kind of joking, but I'm not. I regularly talk with folks, and you know, people think or say or vendors market that zero trust is a network activity. The other thing I want to say is, like, what I talked about is only the runtime side of zero trust. That's the easy part. The people process changes are the hard part. So I totally skipped over those. So what arguments to make for the network team? One, the agility argument that I made. So what is the time to change a policy, and is that hurting development agility, right? And then you can case it in terms of what are the features that aren't getting deployed to our users because of network pain, because of the time it takes for us to do things like policy changes, right? So that's one angle that I would attack it at. The other one is just that, again, you know, the security that you need these authentication and authorization pieces as well, right? And so the network can do only a portion of that. We really need a stronger identity, certainly at the user level, but additionally, we would like that at the service level too. And so those are kind of some of the things I would harp on, because, you know, and you can start to get into things like the layer 7 controls. So for example, you can say, hey, it's not just that the front end can call the back end. I could have a micro-segmentation policy that models that. But you can say, hey, the front end can only call put on the back end, only that one method, right? That's something that a traditional network policy could not model. And then we can go even further and say, hey, you can only call put in the presence of a valid end user credential if that end user credential has the right scope. In a put case, a right scope, for example, right? And so, you know, hopefully it's pretty clear for folks why that would be a tighter boundary or a better security posture than strictly a network-oriented one. So that's how I would start to do it. But legitimately, the reason I helped write some of these with NIST is to move the ball for those teams. So for folks, especially that are in banking, for example, the FFIEC has already included some of this stuff in their guidance and in their IT handbooks. So if you're in the banking or financial spaces, go pull up the FFIEC IT handbook on architecture, and there's a microservices section, and it cites all this stuff, right? So that would be your justification in that kind of an industry, for example. So it may or may not help yours, but, you know, in different industries, we're actually already seeing these guidelines be enforced as standards.
Okay, thanks. We talked, by the way, and so I'm pretty sold on service mesh. We're using it in production in a couple different places.
Awesome.
A lot of what you're talking about here resonates really well.
Awesome.
I'd be curious, you know, you work on these, you know, NIST white papers. The one thing we worry about is there's a bit of an obvious trade-off that you worry about all of the power of the centralized control, but I think now at this point, if I'm an attacker of the typical Kubernetes system, what I really want is to take over HTTP.
Oh, for sure. Right? Yeah.
Like that's my attack vector I'm looking for. And
correct.
It's kind of the obvious trade-off, and I wonder if you could speak to that a little bit. Is that something you guys think about?
Yeah, it definitely is. And this goes back to that core idea of the service mesh potentially being the kernel, right? So one of the implications there is that the kernel in the operating system, the kernel code gets pretty close inspection. It gets a lot of security review. There are a lot of bug bounties. There's a lot of value in finding a kernel exploit, whether you're white hat or black hat. There's a lot of value there, and the economics of the environment are set up to help, you know, to hopefully make that so you're going to turn it in and do that. We do similar things with the service mesh. The whole idea of the kernel is that for the high, so, you know, would you rather have a service mesh that's tackling these security postures and one code base that you audit? All the enforcement happens in Envoy, so let's do security audits on Envoy data path. The control plane configuration happens in the control plane, let's do audits on that. Or if instead we could do encryption, the auth-in, the auth-z for end users and for services in every app, right? And so either that's app devs writing it 10 different times or 100 different times, or hopefully you've got a central, you know, you use a library or something like that, right? But the point is there's one code base that we can audit as opposed to many. And because that's a shared code base and it's open source and things like bug bounties already exist for the Istio code base, we can have some higher level of assurance that it's secure. So there's no magic there, right? Just like the operating system kernel is the attack vector that people are very interested in the distributed world, the service mesh is going to be too. And so that's where you see, you know, I think all the service mesh vendors have pretty robust security practices. The Linkerd folks have pretty good practices there. I know firsthand that Istio security practices in response to CVEs is excellent. And so, yes, it is something we think about deeply. We know it's an attack vector. It's the clear thing you want to take over. And so the point is, we can focus our inspection there. We can focus our security audits there and gain assurance for the whole system.
For definitely a big fan of propagating service principles as well as user principle context across vertical.
Yeah.
As you hinted at with Istio particular service mesh, you can propagate service identities through DNs, through
Yeah.
Mutual CLI.
Yeah.
What do you think about what do you think about that versus pushing it up slightly further at layer 7?
Yeah.
Into, say, JWT, a token.
For sure.
Delegation standard.
Yeah, so there's actually prior art in this space. There's a Google page. So SPIFFE is the specification, the secure production identity framework for everyone. SPIFFE is what the service mesh, all the service meshes today use for application identity. SPIFFE was created by Joe Beda of Kubernetes creation fame. And SPIFFE was actually loosely based on Google internal technology called LOAS, which a few years ago was, there was a white paper written on that they called ALTS. They called it Application Level Transport Security. And so exactly what you're talking about. That has an interesting set of capabilities. So if we do it at that layer, we can do things like propagate multiple service. We can propagate like the service chain. The front end called the back end called the database. So then we don't need to look at policy that's pairwise. We don't have to say the front end called the back end and the back end called the database. We can have the full provenance of the call graph, and we can make a decision on that. We can say, hey, the database can only be written to if the requests traverse the front end and the back end and only these methods of that, right? But it can only be read if it traverses these paths, right? So there's a huge amount of power in having an application level application identity or service identity, right? But today, one problem there is you still need to handle encryption in transit. And that's fine. There's a lot of ways to do that. That's not a huge deal, but you do need to handle it. And then two, there tends to be more runtime costs there. And so a lot of folks have not pursued that one because due to that chaining, you tend to have to reissue JOTs. And so there's a lot of signing pressure on your JOT server. And so there's a set of trade-offs there, basically, at runtime. We've seen that it's pretty decent to do MTLS for app identity, but there's plenty of prior art for doing service identity in the app level in a thing like a JOT, and even nesting the JOTs and having end user and service JOTs together. All of those are good and valid. You don't have to do it with SPIFFE and MTLS like the mesh does.
And you talk about the identity security. How do you see the role-based security and the mesh service?
Yeah. So how do we see RBAC, role-based access control, and I assume other access control paradigms when it comes to the service mesh? And the answer is, when it comes to authorizing service-to-service access, use what scheme works well for you. So in Istio, there's a native authorization API that is an RBAC-style API. And so in that world, if you're doing just pure upstream Istio, you're just writing straight RBAC, basically, and that's kind of the only option you have when it comes to service-to-service access. There's definitely other schemes out there. So plenty of folks implement it with, something like OPA, Open Policy Agent, and they encode their policy about service access there. And that has a very different, manifestation and policy language comparatively, but from the point of 207A, we don't really care what the authorization mechanism is. I can say that if you go read SP 800-204B, we make the strong argument that next generation access control, NGAC, is the access control system you want to be using for service access. It's a modern ABAC. It'll be a topic for another talk maybe, but that's one of the key areas that I do research in, is access control in general and next generation access control specifically.